Now you have a branch coming here called emergency, all right? It's coming in here like this, okay? And at the same time, in this same emergency, it's passing over something else here, then it splits into parts. One part goes up like this, another part goes down, and the third part goes to the right, like this. All right, very good. So what is this about? Or how should we think about this? Look at how, the first thing, who is S1? This S1, which is drawn with an arrow like this, is essentially a push button. So what is this push button? It's basically something called select, all right? This push button is present next to the equipment itself. How does the process work? There are several ways or forms you will see throughout the Arab world, whether in Saudi Arabia, the UAE, Bahrain, even Qatar, or even Egypt, all right? Nice. The idea is quite simply that you have on the cells, either for each one present, it is next to it, all right? Nice. Whatever is next to it is close and open. Either you have a close and an open common, meaning that if you press close, it closes whatever is there. How will it know if I want to close the breaker, or I want to close the disconnector switch, or I want to close the air switch? Next to each component, there is one button called select. You press it and keep pressing it, then you have two general close and trip commands. Two general close and trip commands. All right, one close and one trip for the general. So if you have selected the breaker and pressed close, this close is supposed to go and shut off all the equipment, or what is called in Egypt mohimat. If we say it in Arabic, or all the components you have, whether it's the disconnector, earth switch, or circuit breaker, it sends them all a close command, but the circuit is not complete because you haven't pressed your select button. So what you will press is the select button and then press to close. This is the only one responsible for closing. All right, great. So if you press here emergency, you have chosen the emergency mode, and through your DC circuit, meaning you selected emergency here, this is closed. What does this mean? It means the positive went here like this to the emergency branch, and the negative is not related to this matter. The important thing is that the positive has reached here. You came, sir, and pressed the push button called select. You pressed the push button, all right? As soon as you pressed the push button, the post brought you down here, and you got K3001 here. Who is K3001? It told you, well, this is located in 9A E7. What does 9A E7 mean? It means page 9A, and the page before it is page 9A. And E7. And here is column number 7. And here is column A, B, C, D. Here is E7. Here is K301. So, who is K301? If you look up here, it is written for you so you can read it. Here is K301. All right. And here is K302. It is written above for you. Control signaling close and control signaling open. It is written above this and that. This is an auxiliary relay, and that is an auxiliary relay. The idea is quite simple. You have here a push button named S51 and a push button named S52. This push button is called general close for the entire circuit for any component or any task you have, all right? And S52 opens any component you have. This is the open support. So if you press close, okay, all right, and you don't press open, keep in mind what the push button itself does. It has a normally open contact and a normally closed contact to prevent you from playing around and pressing close and open at the same time. What did it do? It said, well, if you press close and don't press open so that this remains closed, then DC will go here and activate the coil of the auxiliary relay named KIM, which is called KIM 301. All right, and if you press open and don't press close, this is also the same. Normally closed contact from the same push button. At that point, it will activate the auxiliary relay coil, or the coil of the auxiliary relay named CAM K302. So what he did here is to ensure that no one presses close and open at the same time. What he did is take the push button for close named S51 and use a normally open contact to give the close command. At the same time, he took a normally closed contact from the same push button and placed it in series in the path of the open command. So if you press close, this will close and that contact will open. All right, so if you press both close and open at the same time, what will happen? Neither close nor open will occur. Why? because this is closed since you gave the close command, and this is closed because you gave the open command. But this is open because you gave the open command, and this is open because you gave the close command. So the DC won't pass through to go to open, nor will it pass through to go to close. Clear. The very important thing is that you indeed gave me the button that as soon as you actually pressed it, the parts that are certainly called worked, activated. When it truly worked, it absolutely closed what you had here. And you were then assured that this brought you a close, and that brought you a close. So this means it passes through here and goes all the way down. All right, that's good. This is the first path. So what is the second path? Let's see together. The second path is if you press emergency and choose close, you will go up. No, actually, you won't go up. In reality, it brings you down. You're not going up. Okay, this is another line, a barrel with your track. So where is this coming from? Let's see together if you look up a bit with your eyes. All right, you will find that if you have chosen the local mode, meaning you selected the local mode there, it won't have a positive. But what will have a positive? It keeps going like this, going like this, going like this, and then it comes up here. Who is this? This is the PCU. Who is the PCU? It is what is called the P control unit. What does P control unit mean? In the past, or even in old stations up to now, if you enter any old station, you will find the leaders. You will find that in the station, in the GIS or the switch gear. We used to call it local. So you will find a selector switch on the panel if you want to control the local robot. If you tell the robot, you go to something called the control room, which is the control room, and you will find something called the mosaic panel, which is a set of panels arranged next to each other with a complete single line diagram drawn on it of the station, and on it all right, and on it there are some parts which are the whole idea of this country based on a single line diagram. You can monitor who is closed and who is open, all drawn next to each other at the same time. You can control opening and closing at the same time. You have an energy meter from which you can take readings, and you have an annunciator, but it's a bit small, taking the alarms present in the S side, but in the form of aggregated alarms. All right, very good. What did he do? He told you to just use this control room. I will do something very simple. I will bring an IED, which is an intelligent electronic device, and install it in my cell, in my panel, all right? In the LCC panel itself. So instead of bringing cables or connecting them from the LCC or JS room to this control room, which would cost me money, and a control room means space, which would also cost me what? Money. And equipment and panels would cost me money. I will bring just one relay and install it in the LCC panel. And the statuses, alarms, readings, and everything will be sent to this PCU. The PCU will be installed with me in the same panel. So the wires obviously won't exceed a few meters, all right? Very good. And then this PCU, which is the Bay Control Unit, acts as the control room that used to exist or is present in old station units. What does it do? You can monitor from it, you can get readings from it, you can see what is closed and what is open, and you can also control from it. All right, in the past, this control room was connected to the SCADA system. So you had the control room, which would then output protocol 101 or 102 and go to something like the RTU or others. All right, we would go to the gateway, and from the gateway, we would go to the SCADA. But now, no, we don't have that anymore. What do you have now? Now, I have the PCU itself. The PCU, fiber optic communication, is a method of transmitting data using light pulses through optical fibers. This technology is known for its high speed and efficiency pop. You can connect it to a system called a SysSystic, which serves as a specialized interface. A SysSystic allows for seamless integration and communication between different networks, ensuring data is transmitted accurately and quickly. In large data centers, SysSystics manage the flow of information, ensuring smooth operations. This integration is crucial for modern communication systems, providing the backbone for internet services and other digital communications. This computer is the one that then receives the fiber cards. Of course, they are initially connected to the switches. This gathers all the relays in the station, and finally, I exit from this switch with a fiber cable to enter into what is my computer, which is the case that we liked, the case of my computer. All right, it enters into the card from which you can draw or monitor your system and see this diagram as it was in the mosaic. You can control, take readings from it, access these relays if you want to change anything. You can do whatever you want. This relay is called a PCU or P control unit. So it tells you that the emergency mode means what? It means that you pressed select from the same cell and pressed close. So you are standing in front of the cell, pressing select and close on the buttons available in the cell. However, if you choose local, you will find the post coming here like this and going here like that, where it goes to a terminal or a terminal block. And from the terminal block, where does it go? It goes to the PCU. What is the PCU? The PCU is essentially a logic diagram drawn inside with function blocks. A block usually consists of two function blocks. Whether you're working with Siemens 6MD, for example, or with ABB Rec 670, or even with the MyCom P264, any of them, the important thing is that initially in SEL 451, for example, you have some logic diagrams inside that you can create. This logic diagram is graphical, or you can write it as commands. But of course, most of it is graphical, or all of it is graphical within the allowed SEL graphical limits by writing it in the form of an equation. The important thing is that you can, from the relay screen itself, look at the single line diagram and choose that you want to close the breaker. When you select it, a specific output contact from this relay closes. So what does it mean when it closes? It means the pulse has passed here from the local, went up in the PLC, and if it's closed, it returns back here, goes down, 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 and goes down further. This is the concept of the PLC or the local mode. All right, so if you choose remote, what will you do? Well, with remote, you will also come here to the terminal block, and the terminal block goes to the PLC, and the PLC closes, or with the contact, it returns here as well, goes down here too. So what's the difference now between local and remote? The difference here won't be visible in the drawing in front of you. The difference will be in the programming of the IED. What does this mean? It means when you choose local, if you go to the PLC screen and give a close command, it will accept it if you have chosen local. If you choose remote and go to the PLC screen and give a close command, it will tell you you are not authorized relay in remote mode. The phrase relay in remote mode means that in your logic, the close command must come from the SAS, the substation automation system. The base engineer must acknowledge in front of the computer, he is the one who presses, he is the one who gives the close command. The same output contact is present with you. It is the same output contact that will close to give the close command. But one of them is controlled through the PCU screen itself, if you choose the local mode, and the other through the SAS if you choose the remote mode. All right, I have come down here and placed the post here. Yes, so here in the emergency position, I will press select and general close. As for the local and remote positions, I will go to the PCU, take from it, or connect and switch between them down here. Up to this point, these two will converge at one point. If you go down here like this, or you can go right, that's fine. So you have a choice. Either go down or go right. Going down, we call this the test position. If you go right, then you are heading to the service position. What does this mean? Let's see together. Now, as an engineer, you have the single line diagram of the cell, as you can see. I have provided you with the actual numbers from the substation. Here, this switch is 627, along with a ground, which is a series position switch. But I have drawn the diagram separately for you. K631, and here you have D629, and you have the breaker. K6111, and you have the ground, which is the ground disconnector. D630, K633, and you have the high-speed air switch, or the line air switch, which is K635. Clear? Nice. Okay, now I want to close the breaker. When we explained the single line diagram of the double bus single breaker, we agreed on the concept that the disconnector and ear switch are things that do not open or close on loads. Only the circuit breaker opens and closes on its loads. So to close this circuit breaker to the on position, either you close it in the test position, meaning in the test mode because it is under maintenance, or you close it in the service position, meaning you now want to close it in the service mode and connect it to the electrical power. Okay, now if you want to close this breaker in the test position, what does that mean? It means you need to isolate your circuit breaker. We agreed that in the switch gear, the breaker but can be pulled out. And I said here that I can't pull the breaker out, it's all inside. The size of the breaker is large, meaning you can't handle it as an individual. All right, remember when I told you that this is named based on its ability to connect or disconnect on the bus bar so that it can choose to look into it and operate. At the same time, what else does it need to do? It needs to perform isolation. What does isolation mean? Isolation means that when I want to perform maintenance on the breaker in the switch gear, I used to pull it out through the side. So what do? I open this disconnector and that disconnector to isolate the breaker from the bus bar. And at the same time, I open the disconnector, which is D32, to disconnect the breaker from the live. This is what we essentially call interlock. What does the word mean? In essence, it means that before you take action with me here, in order to close my breaker, which is specifically referred to as such, I must ensure that the 3 breakers before and after it are indeed open. Great, nice. If you confirm that the 2 before it and the 1 after it, these 3 together are open, then I'm sure that this breaker is in the test position. Someone might say to me, but you explained to us and told us that even if it's open, I might get from the upper and lower bus bars, those that are before, to the part that comes after this one. Or you might also get something called induced voltage from the line. You told me at that time that in order to discharge, the static charge is present, or this induced voltage, to bring it down to 0, what do? I must have a ground before and a ground after the breaker so that I can reach the 0 voltage point. And as a person dealing with the breaker, I am then in a safe position. This is done by grounding, guys. So is it a condition, engineer, that in the Kingdom of Saudi Arabia, in order to close the breaker in the test position, I must necessarily have a ground before and after? No. The only thing that must be verified or must happen is that the blades before and after must be open. The matter of grounding is up to you as an operator to close it as a safety measure for yourself, okay? Or as a person in charge of what? Or as a person in charge of? Is that clear, engineers? Very good. So you will come here, engineer, and what will you find? You will find a large box with dots. This dashed line box means that it is something outside the cells, but inside this, there are 3 other things as well. Here you have this box marked with dots, and here you have one, and here you have another one. Each of them contains a block inside. A black square block. So we said this means, where is it coming from? It's coming from the mechanism box, right? The mechanism box in the JS. So here it's coming from the mechanism box, and the same goes for this one and this one from where? From D627, D629, D630, from these guys. Come and look here. This is D627, D629, D600 something. 31. So now I have come to understand that these 3, the 3 things inside these boxes, are indeed coming from D26, D29, and D31 specifically as follows. Very excellent. Okay, great. Then let's see what's inside them. You need to go to page 21 to find out what's inside them. If you go to page 21, you'll know that this contact carries the state of the switch, and it's the same for the others. Okay? The rule after that, we agreed that the breaker, we said the first thing is the MCB, or the miniature circuit breaker. Everything drawn in your drawing is depicted, and it is before. Everything is drawn. In a position here, as we said, it is depicted in its natural state as not being charged. Okay? Great. Then we come here to the knives. All the knives, engineers, and the grounds are now drawn. They are drawn as if the knife, the knife itself now. Engineer Rashad, it was normally closed. Yes, normally closed in any position if the knife was open. That's why it is now drawn as normally closed. And indeed, that's what I want. Because whether I give a close command when I press select with close in an emergency situation, or I choose the local or remote mode and give a close command from the PC, or I go and give a close command from the SAS, in the end, they will all come here in 2 positions. If you go down here, then here we are talking about the branch, or the difference related to the test mode. To stop the breaker in test mode, 3 knives must be open. So here, this contact indicates the knife is open, and the same applies here and here. As long as the disconnection is open, this contact is closed, this contact is closed, and this contact here is closed. So in the end, they all tell you what? They bring you a position opened here, Great, okay. And then I come to this point, or now I have reached the time where I am in emergency, local, or remote mode, and you have the 3 knives or 3 switches open. I went down to our level, all right. At the same time, engineer. I now have a branch coming out here as well, all right, my dear. What does this branch say? Focus with me. This branch, if you go to it like this, you will also find the same selector switch, taking another context from it here as well. Off, emergency, local, and remote. The off is not used for anything, but you have emergency, local, and remote. All right, very good. If you notice it like this, or to understand it simply, if you choose emergency, local, or remote, and give a close command in the emergency position, or a close command in the local position, or a close command in the remote position, and you turn them all here, all of them, plus the snags, if they go down like this, it means that the breaker is in the test position. This means for this loop to complete downwards, the breaker is in the test position, meaning the 2 blades before the breaker and the blade after the breaker are all open. That's why this contact Abu is normally closed as agreed. Is that good? Good. Okay, if you go in this direction here, it's written service on it. So you would immediately expect that the direction I'm going down is the service position direction for the circuit breaker, whether you have chosen emergency, local, or remote. If I have chosen emergency, that's great. If I have chosen emergency, then the same selector switch will have the emergency contact closed. And if I choose local, I will find it closed. And if I choose remote, I will find it closed as well. These are also contacts from the same selector switch, right? Am I wrong? You told me right. Very good. Now let's assume I have chosen emergency, so it's closed. As soon as I press select and close will come here. This time bringing you DC if the breaker, HE, is not in test mode or not in the test position. What does that mean? It means a knife switch might be closed, so this branch is not complete anyway. Let's assume this 627 is closed, so the contact is open, and the positive will reach here and find this path open. Does it have another path? It will come here, go like this, enter here, and find itself in the emergency. After the emergency, it will ask itself a question. And here, if it was set to local or remote, when it gives or remote, the post will still come to this point, look down at the knife switch, and find it open, or find one closed or a different condition, understanding that its test position is not complete. So it will look at the other branch of the service, come here, and find itself local or remote, then go down here. So you have the emergency bringing you down here, and the local and remote bringing you down here. What do these two need? These two, engineer, need to meet the synchronization conditions. What does that mean? Now, you are closing the breaker in the service position. What does it mean to close the breaker in the service position?